Hello and welcome back. I'm Benjamin Williams, and today we're within the Boson NetSim infrastructure section. And today we're going to be doing some troubleshooting on spanning tree protocol. So let's go ahead and read our objectives for this lab. It says analyze, locate, and fix spanning tree protocol (STP) problems on your network, which can be caused by misconfiguration or incorrect design. So we can see our lab topology that we're working with for this lab. We have PC1, PC2 connected up to our access layer switches. Of course, our access layer switches are going to give our endpoints connectivity to the network. From our access layer switches, we have redundant connections running to our distribution layer switches. So that's always good. STP is going to block one of these links. And if one of them goes down, that other link will be enabled, so it'll have another path to get to the distribution layer switches. Of course, our access layer switches are going to usually be our layer 2 boundary. And then once we get up to the distribution layer switches, that is going to be our layer 3 boundary. Our distribution layer is going to be in charge of aggregating all of our access layer switches. And if PCs need to communicate with each other, that will be done usually within the distribution layer, because this is our layer 3 boundary. Then we have some redundant connections connected up to our core switch. Our core switch is going to aggregate all of our distribution layer switches. So if traffic needs to go to the, outside of the network, such as the data center, or if it needs to go to the WAN, if it needs to go to the internet, etc., that's what the core switch is going to send that out to the routers, and then the routers is going to route the information from there. So usually that's the way that you would have if you have this 3-tier hierarchical design. But this is a lab, so 9 times out of 10 we're going to be running spanning tree on all of these switches. But just looking at it from a real world perspective, that's usually what you would have. But this is a lab, and it's always good to have different hands-on experiences with these devices to learn a lot more. So we've read through all of our commands and our descriptions for this lab. So let's go ahead and get into it. We're going to do our usual. We're going to do all of our configurations down here at the bottom. We're going to keep our lab topology top left. We're going to be doing all of our readings top right. So let's go ahead and get into our first lab task. It says complex network troubleshooting requires a structured approach. Network documentation that includes thorough troubleshooting procedures can decrease the amount of time required to resolve network problems. Troubleshooting procedures should contain a process to diagnose problems and the steps necessary to verify that a proposed solution resolves the problem. In this lab, this is referred to as a troubleshooting and verification plan. So it says trouble ticket number 1, bad switch optimization. So it says hot standby routing protocol, HSRP, which is a first hot redundancy protocol, was recently implemented on R1 and R2. Although you have not had administrative access to R1 and R2, you have been informed that R1 is configured as the active router for VLANs 1 through 3, and R2 is configured as the active router for VLANs 4 through 6. You have also been informed that some portions of the network are sluggish at times, unresponsive under heavy load. In this task, analyze the network and determine the cause of the problem. Okay, so it said that we have HSRP configured on R1 and R2. So, and it says that R1 is supposed to be the active router for VLANs 1 through 3, and R2 is supposed to be the active router for VLANs 4 through 6. Okay, so let's just check out our spanning tree configuration. And the reason that I say that is because we just want to see where our root bridge is located on this network, because we know that R1 and R2 are our HSRP routers. So traffic, if it's going outside of the network, is going to be sent to either R1 and or R2. So we want to make sure that that path is optimized. So let's do a enable. Let's do a show spanning tree. Okay, so let's check out a switch 1. Is it the root bridge for any of these? Not for VLAN 1, not for VLAN 2, not for VLAN 3, not for VLAN 4, not for VLAN 5 or 6. Okay, so a switch 1 looks to be good. Let's do an enable over here. Let's do a show spanning tree. Okay, so a switch 2 is not the root for VLANs 1, 2, or 3. But it seems to be the root bridge for VLAN number 4, VLAN number 5, and VLAN number 6. So this is an issue. And the reason I say that is because our HSRP routers, which is going to be our default gateways, the traffic is not optimized if A switch 2 is our root bridge. Our traffic will have to come back and make more hops to get out to the routers. So we probably need to change this from not being the root bridge and let either one of our distribution layer switches or our core switches, really our core switches, be the root bridge, since these are our HSRP routers and our default gateways. So let's go over to D switch 1. Let's do an enable over here. Let's do a show spanning tree. Okay, and we can see that D switch 1 is the root bridge for VLAN number 1. It's the root bridge for VLAN number 2. And it's the root bridge for VLAN number 3. Okay. So what I'm going to do is, since A switch 2 and D switch 1 are our root bridges, let me do a show run on both of these. Let's do a show run over here. Okay, so we can see that spanning tree for VLANs 4 through 6 was configured with a priority of 24,576. Of course, like I said, this is not optimized because A switch 2 is at our access layer, and we really want one of our core switches or distribution layer switches to be our root bridge. So we know that this was configured with a priority other than the default. Let's go over to D switch 1. And let's do a show run. And we can see that VLANs 1 through 3 was configured with a priority of 24,500 other than the default. And it looks like it's the backup. D switch 1 is the backup for VLANs 4 through 6. So if A switch 2 was to fail, D switch 1 would take over as the root bridge for A switch 2. So let's go over to A switch 2. Let's do a configure terminal. We're going to remove that configuration. Let's go. Let's do a no spanning tree for VLANs 4 through 6 root primary. Or we can do a priority. We can just do the priority of 24,576. So 24,576. Okay. Let's do the same thing over here on D switch 1, because what I'm going to do is I'm going to make the core switches our root bridge, just because that's going to optimize this topology the most, because like I said, R1 and R2 are our first hop redundancy routing protocol routers. So let's go over here. Let's do a configure terminal. Let's do a no spanning tree VLANs 1 through 3. Let's do a priority of 24,576. And let's do a no spanning tree VLANs for 4 through 6. A priority of 28,672. Perfect. All right, let's go back over to A switch 2 and let's do a do show spanning tree. Oops, I got too many ends. Spanning tree. All right, so we can see now for VLANs 4 through 6 that A switch 2 is not the root bridge, which is what we want. Let's go over to D switch 1. Let's do a do show spanning tree. And we can see right here that for VLANs 1, 2, and 3, that D switch 1 is no longer the root bridge. Okay, perfect. Now let's go over to our core switches. This is where we want to have our root bridge. Let's do a configure terminal. Let's do a spanning tree. And since, what does it say? It says R1 was configured as the active router for VLANs 1 through 3. So we're going to make this connection right here a root bridge for VLANs 1 through 3. And then for core switch 2, we're going to make that the root bridge for VLANs 4 through 6. So on core switch 1, let's start out with VLANs 1 through 3. Let's do a VLAN 1 through 3. And let's do a root primary. Oops, root primary. Got caps lock on. Primary. Ooh, still on. Perfect. Okay. Let's go over to core switch 2. Let's do an enable. Let's do a configure terminal. Configure terminal. Let's do a spanning tree for VLANs 4 through 6. Oh, I got VLAN instead of VLAN. VLAN 4 through 6. Let's do a root primary here. All right, and just for backup purposes, I'm going to do a spanning tree VLAN 4 through 6 over here, just in case core switch 2 fails as the primary root bridge. We're going to allow core switch 1 to take over for it. So let's do a root secondary over here. And let's do the same thing on core switch 2. Let's do a spanning tree VLANs 1 through 3 root secondary over here as well. Okay. So let's just confirm my configuration. Let's do a do show spanning tree over here. And we can see that core switch number 1 is our root bridge for VLANs 1, 2, and 3, which is what we want. And core switch 2 should be our root bridge for VLANs 4 through 6. Let's do a do show spanning tree. Okay, so we can see for VLANs 4, 5, and 6 that core switch 2 is our root bridge. So that's what we want. Our network is now optimized. So it doesn't have to, PCs don't have to go through many more hops to get to their HSRP default gateway. Instead, their root bridges is now core switch 1 and core switch 2. So basically the traffic is optimized. It doesn't have to go through extra hops to get to its HSRP router. So that's what we want. Okay, so let's go ahead and move on to trouble ticket number 2. I think I solved trouble ticket number 1. We'll see whenever we hit that submit button. So it says trouble ticket number 2, traffic shaping due to faulty switch. It says a network engineer has warned you that D-Switch 2 is producing numerous errors and having problems delivering traffic. D-Switch 2 is currently the primary distribution switch for half of the VLANs in the network. A new switch has been ordered to replace D-Switch 2, but in the meantime, you must mitigate all the primary traffic off of D-Switch 2 until the new switch can be delivered and installed. First, you should analyze the network to determine which ports are connected and forwarded to D-Switch 2. Then, because D-Switch 2 will be decommissioned soon, you must route all traffic through D-Switch 1 to avoid problems that could be caused by potential hardware failure during business hours. So you do not want that to happen. You do not want hardware failures happening during business hours, because then your company or whoever you're working for, people can't connect to the internet. So let's go ahead and optimize this right now. Let's go over to, first, let's go over to a switch number 1, because our access layer is really the ones that's connecting up to our distribution layer. So let's look over here. Let's do on a switch 1, let's do a show CDP neighbor. So we can see that our fast Ethernet 03 and 04 are connected up to D-Switch 2 right here. Okay. Let's go over to A switch 2 as well. And let's just do a do show CDP neighbor. Okay. And we can see right here that fast Ethernet 01 and 02 right here are also connected to D-Switch number 2. So let's do a show spanning tree. And let's look. So we can see that we know that the fast Ethernet 03 and 04. So we need to, looks like we need to change this because that's one of our root ports. So fast Ethernet 03. Fast Ethernet 03 over there. Fast Ethernet 03, Fast Ethernet 03, and Fast Ethernet 0. Okay. So just taking a look at A switch 1. Let's take a look at A switch 2 as well. Let's do a do show spanning tree. And our fast Ethernet 01 and 02 connections. So it looks like we need to change this fast Ethernet 01 to not be our root bridge. So that's for VLAN number 1. Same thing over here. Fast Ethernet 01 over here as well. Same thing with VLAN number 3. Same thing with VLAN number 4. And it looks like for VLAN number 6 as well. Okay, so let me do this one more time on A switch 1. And the reason I want to do that, it looks like we have connections up to D switch 1 right here. But when I do show spanning tree, those interfaces are not coming up in our output. Let's do that one more time. Let's do a show CDP neighbor. And it's not giving me any output for D switch number 1. But it looks like we have redundant connections over to D switch number 1. So I'm not sure why it's not showing me D switch 1 and the output of show CDP neighbors on A switch 1. But let's just go over to A switch 2. And let's do a spanning tree. See, it's some context sensitive. Okay, let's do a VLAN 1 through 6, really. And we want to configure the priority. Well, first let me go into interface fast. Let's go into interface range. Fast Ethernet 1 through 2. Okay. And let's go back up just to confirm. I'll show CDP neighbors. So we want to configure both fast Ethernet 01 and 02 to have a higher cost for D switch 2. So traffic doesn't go to D switch 2. It actually goes to D switch 1. So let's go over here. Let's do a spanning. And we can see our priority right now, our cost for fast Ethernet 01 and 02 has a cost right here in this column of 38. Let's up this to like 100 or something. So it is not a desirable path. So let's do a spanning tree. Let's do a spanning tree for VLANs 1 through 6. And let's do a port priority cost of 100. Or does it need to be the port priority? Or let me make sure that I'm doing that right. I may need to just do the cost. Yeah, let's do the cost. We don't need to do the port priority. Let's do the cost of 100. Okay. Now let's do a show spanning tree. And now we can see that Fast Ethernet 03 is now our root port, and the cost for these Fast Ethernet 01 and 02 interfaces now has a cost of 119, which is what we want to see. It is no longer our root port. So we wanted to get our root port off of D switch number 2 and make it forward through D switch number 1, which we just did, because this Fast Ethernet 03 connection is connected up to our distribution number 1 instead of our distribution number 2. Now our Fast Ethernet 01 and 02 connections was connected up to D switch number 2, which is what we didn't want. So let's just confirm that one more time. Let's do a show CDP neighbor. So as I said, we can see Fast Ethernet 01 and 02, D switch 2. Those are now not root ports. Our Fast Ethernet 03 is now our root port. And as you can see right here, that's connected up to D switch 1, which is what we want. So everything is looking good there. Let me just go back to A switch 1 more time. And I'm not sure why. Let me do a show CDP neighbor over here. Yeah, so traffic, I mean, it's not showing anything for D switch number 1. Not sure why. Let's just go over to our last step. Hopefully we did this right. If not, we'll correct it. It says trouble ticket number 3. It says configuration error causing unstable STP. So it says a network engineer has informed you that ports on A switch 1 are in the error disable state. So that may be the problem. It says your task is to determine the problem, determine the cause of the problem and correct it. After correcting the problem, you should verify that A switch 1 is using the efficient path to send traffic to the root bridge for VLANs 1 to 3. Okay. So, let's go over to A switch 1. And it says that one of our interfaces is in the error disable state. So usually that happens when BPDU guard is enabled. So let's make sure. Let's just do a show interfaces status. Okay. So this may be the reason why we're not being able to see D switch 1 in our output. As we can see, both of the connections, which is fast Ethernet 01 and 02, are in the error disable mode, and 9 times out of 10 those are the two connections that is connected up to D switch number 2. So let's figure out why these ports are in the error disable mode. Let's do a show run just to see our configuration. Right, so yeah, it has BPDU guard enabled. So this is connected. Fast Ethernet 01 and 02 are connected up to our distribution layer switch. So as soon as those BPDUs are received on A switch 1, it is going to disable that port and put it in the error disable mode. I'm not sure why BPDU guard was enabled on these interfaces. Usually you would enable BPDU guard on an interface or a port that you have port fast enabled on, and that usually is towards our access layer or our NPCs like PC1 or PC2, not in the direction of another switch. That is not good to have. Those interfaces will go down immediately, like we're seeing in this lab. So let's take BPDU guard off of both of these interfaces. Let's go into configure terminal. Let's go into interface range, fast Ethernet 01 through 2. Okay. Now let's do a no BPDU guard BPDU. Did I spell that right? No spanning tree. Yeah, I forgot to put spanning tree. BPDU guard enable. Okay, just to take that configuration off. Now let's go. We're already in interface range mode for 01 and 02. Let's do a no shutdown now. Well, let's do a shutdown and let's do a no shutdown. Right. So now those are back in the up state. So now if I guarantee you, if I do a exit and I do exit again, and I do a show CDP neighbors, I guarantee you I can see D switch 1 now on this output. Okay, so we still don't. So maybe it needs some time. Hopefully it comes up. Maybe not. Maybe that's just the way that this lab is configured to do. I'm not sure. Let's do a show interfaces status. So we can see that our fast Ethernet 01 and 03 connections are up. Let's do a show spanning tree. Show spanning tree. So we're able to see these ports up now. And fast Ethernet 01 is a root port. It's a root port. And it's forwarding to D switch 1, which is what we want. We don't want anything going to D switch 2. So I think it's going in the right traffic is flowing in the right direction and be optimized, because we want all traffic to go through D switch 1 and not D switch 2. Let me do this one more time. Let's do a show CDP neighbor. There we go. Yeah, it took a while for it to propagate into the output. Now we can see that we can see D switch 1 from A switch 1. So that's what I really wanted to see. And we know now that traffic is flowing through D switch 1, which is the fast Ethernet 01 connection. We can see that right here. That's connected up to D switch 1. So I think we completed this lab right here. let's make sure it says you determine the problem and correct it. At correcting the problem, you should verify that a switch 1 is using the most efficient path to send traffic to the root bridge. So it is. So we just answered that question. Let's go ahead and grade, and hopefully we got everything correct. So it looks like we have 2 errors on D switch 1 and core switch D switch 2 and core switch 1. So what does it want here? It wants me to, this is my running config, and this is the expected running config. So it wants, I could have sworn I put spanning tree VLANs 1 through 3 priority. Yeah. And spanning tree VLAN 3 priority? That's what I put? Okay. I didn't think I put 2 different inputs for that on core switch 1. So we need to fix that. Let's fix that first. Yeah, let's fix that first. So I already know probably Boson is erroring out. I think it's erroring out. And I can confirm that. Let's do a core switch 1. So it's on core switch 1. So let's go to core switch 1. Let's go back up and see what we inputted. Yeah. So I didn't do what it's saying I did. I actually put in the command the correct way. I did VLANs 1 through 3 root primary, as you can see right here, and I hit enter. If I click grade, it's going to say I did VLANs 1 and 2 and did VLAN 3 in a whole different command, which I did not do. You can see right here in the output, it's saying I did VLAN 3 by itself, which I did not do. So let's see if I could correct this. I think this is an error within Boson itself. And it's not going to probably let me correct it, but I can try. So let's go down on core switch 1. Let's do a no spanning tree for VLANs 1. It said I did 1, 2, which I did not do. And let's do root primary. Take that off. And let's do a spanning tree for VLANs 1 through 3. 1 through 3, root primary. Perfect. That's what I did the first time. And it's probably still going to have that same error. Watch. Yeah. It's going to have that same error, even though I just corrected it. So we know that this is going to just continue to error out. There's nothing I can really... I can try to do no spanning tree VLAN 3 priority. Let's try that right quick. Let's do a do show run. I don't know why it's doing that. Oh, let's do that one more time. Let's do a do show run. Hit enter right there and hit tab. Okay. So I want to do a no spanning tree for VLAN 3 priority, whatever is configured, which is 16,384. Let's do a do show run now. Okay, so now we see that configuration is going. Perfect. Let's do a no spanning tree VLANs 1, 2 priority, which is 24,576. Let's do a do show run. Okay, now we got rid of that. Let's do a spanning tree. Let's try this one more time. Spanning tree VLANs 1 through 3 root primary. That's what we did the first time. Let's do a do show run. Now it's correct. That's what we wanted. That's what we did the first time. Not sure how we got that error. Okay. So now we see we got to check on core switch 1. Let's go over to D switch 2. So we did wrong over here. So it basically wants us to configure the fast Ethernet 07 through 010 to have a cost of 100. Why is that? I want to know why. Why is that on D switch 2? Okay, so let's go over to D switch 2. D switch 2. Let's do an enable. Let's do a show spanning tree. So it wants, what switch is this on? What switch is this? This is on D switch 2. So it looks like this is still a root port for D switch number 2. And I guess it wants all of these ports right here that are connected to D switch 2 to have a higher cost, so traffic is not going through it. So let's go over to D switch 2. Let's do a configure terminal. Now I did make a mistake on this one. So let's do an interface range of fast Ethernet 0.7 through 10. And let's do a spanning tree. Let's do a spanning tree. Let's do a cost of 100. Okay. Okay, I think, no, spanning tree VLAN 1 through 6, cost of 100. All right, let's hit grade now. Yeah, so it's that's good now. Let's just go over to D switch 2. Let's just do a do show spanning tree now. And we can see now that the fast Ethernet 0.7 through 10 are all going to be, they're not going to be root ports. We can see our fast Ethernet 0.5 port is now our root port. And if we do a show, do show CDP neighbor, let's see what ports are connected off of here. So we see our fast Ethernet 0.5 is connected to D switch number 1, which we wanted all traffic to be flowing through that. And fast Ethernet 0.7 was connected to core switch 1, 0.8 core switch 1, 0.9 was core switch 2, and 0.10 was core switch 2. Okay, so let's hit grade, and we got the lab correct now. So thank you guys for watching this one. I'll see you in the next one.